Paper 1, A-Level Chemistry, June 2017. Give the term enthalpy of lattice formation, question 1. So this is the enthalpy change, the energy change, when 1 mole of a solid ionic lattice, try and use the word solid ionic lattice in there, is made from its gaseous ions. So when, say for example, Ag plus gas and I minus gas make AgIs as a solid ionic lattice. Use the data to calculate the enthalpy of lattice of formation of silver iodide. Well, what I'd do first of all to try and help me is try and write the enthalpy of lattice formation equation. So lattice formation, as we've said, is the gaseous ions coming together, 1 mole of them to make 1 mole of a solid, 1 mole of an ionic solid lattice from its gaseous ions. So we should be able to work out the lattice of formation equation. And then what we do is we use these and piece this together. Have we got anything with Ag plus in it? Yes, we have. We've got Ag plus here going to Ag plus gas going to Ag plus AQ, Ag plus gas going to Ag plus IQ. So we've got this coming down to Ag plus AQ. And it tells us the enthalpy change is minus 464. Have we got anything with I minus gas in it? Yes, we have I minus gas coming to I minus AQ. So we've got that equation, I minus gas coming down to I minus AQ. And we've got the enthalpy change is minus 293. Have we got anything with AgI solid in it? Yes, we have. AgI solid going to Ag plus AQ and I minus AQ. We've got that, and we know the enthalpy change for that is plus 112. Now, how are we going to link these together? Ag plus AQ going to Ag plus AQ here. Here to here is nothing because it's the same thing. I minus AQ going to I minus AQ from here to here is nothing because it's the same thing. So if I come through from here round this way, a process called Hess's law, where the enthalpy change is independent of the route taken, and instead of going straight across from here to here, I can come round here and I can come round here, and then I can go up this way. I'm going down in the right direction. I've got the right number of particles, so I've got a minus 464 and I've got a minus 293 to make these. Across here is nothing, and then I've got to reverse this sign to come back up here to here, so it's a minus 112. So it's a minus 464, minus 293 and a minus 112. I'll reverse this equation round, minus 869 kilojoules per mole. The calculation of enthalpy of lattice formation of silver iodide based on the perfect ionic model gives a smaller numerical value than the value calculated. So what's the perfect ionic model to start off with then? The perfect ionic model assumes that there's no covalent bonding. So if it doesn't match, the AgI must contain some covalent bonding. We sometimes call that covalent character or covalent bonding. It's got to contain some covalent bonding. The model assumes that everything is all ionic, 100% ionic, and the fact that it's different must mean that it's not 100% ionic. There must be some covalent character or covalent bonding in there. And in actual fact, because the value in the model is less than the actual value, it means that the bonds in the lattice are actually stronger than in the model because you're getting more energy given out, so it's more exothermic. So if it's more exothermic, then it's going to end up with more stable product, and the bonds are stronger than expected. Identify a reagent that could be used to indicate the presence of iodide ions. So you're using silver nitrate in acid, preferably in nitric acid, silver nitrate in nitric acid, and the observation is that you're going to get a yellow precipitate. Incidentally, if you wanted to check that the precipitate was yellow and it was silver iodide as a yellow precipitate, that you got iodide ions and you made silver iodide rather than silver bromide or silver chloride. Silver chloride is white, and it will dissolve in dilute ammonia. Silver bromide is cream and it will dissolve in concentrated ammonia. silver iodide is a yellow precipitate and it won't dissolve in even concentrated ammonia. So that's a check to make sure that you actually have got the colour does, which is the colour sometimes difficult to tell between yellow, cream and white sometimes, so the use of ammonia will just be a double check to make sure that you've got iodide ions rather than possibly bromide or chloride ions there. The nitric acid in there, the acid is stopped the formation of silver carbonate, which is a precipitate as well, because the acid would dissolve the carbonate and stop silver carbonate forming as a precipitate.